We've got some implicit differentiation here. What more do you want? We've got a curve and we're asked to find the stationary points of the curve. So I'm going to differentiate with respect to x. That will give me 3x squared plus 3y squared dy by dx. You should know how to differentiate when you have a y in there. And now we've got the, to use the product rule. So I'll differentiate, I can just pass the minus 3 through. So I'll differentiate x, which is 1, and times it by y. And then have x and differentiate y. And finally differentiate 48. So there we go. Need to just mess about with this now. Okay, just expand the bracket first of all. So dy by dx, if I factorize that out, I get 3y squared minus, do you know what am I doing? Let's just cancel all the 3's out. Y squared minus x, and that would equal y minus x squared. Okay, and we've got our dy by dx. Now this will be 0 for stationary points. So y minus x squared over y squared minus x will equal 0. And the only way that that can equal 0 is if y equals x squared. But x is not equal to y squared. Like in theory, 1 could work for this bit, but it won't work for this bit. So we just need to potentially bear that in mind. So what we can do is we can find the points on the curve where this is true, because we've now got a relationship that's true for the stationary points, but remember we've still got this relationship as well. So it makes sense to substitute in for y. Replace all our y's by x squared. So x cubed plus x squared cubed minus 3x x squared is equal to 48. X to the 6. Now this is minus 3x cubed, so it's going to be minus 2x cubed overall, minus 48 equals 0. We've got ourselves a hidden quadratic. You can see this power is double that power there. And it's up to you. Sometimes people like do a substitution, let z equal x cubed, for example, or you can just go ahead and factorize in terms of x cubed. Two numbers that multiply to give 48, 6 and 8 jump out because we're quite close. We need this minus 2, that will work. So minus 8 and plus 6. So x cubed is equal to minus 6 or 8. And x will equal the cube root of minus 6 or 2, which is the cube root of 8. Now let's find out the value of y that goes with that. So when x equals 2, and by the way, we can see that x is not equal to y squared. We don't have like a 1 or anything there, so we don't have to actually stress about this. But we've got x, so now we need to square. So we're going to get that y is 4, and we get 2, 4 as our coordinates. And then x is the cube root of minus 6. Y will be, well, maybe it's best, well, we can square inside actually. So it would be I kind of prefer to write it as minus 6 to 1/3. So actually it's going to be minus 6 to the 2/3 when we square it. And squaring it means we can actually get rid of that negative. So, you know what, I'm just going to leave it, sorry. We can actually bring that inside as well, can't we? So it could be written as the cube root of 36. Okay, that's a bit neater. So I'm just going to put a little box around this. We're not actually done, but we have found the stationary points. Remember though, we were also asked to determine their nature, so that's something to do now. And to do that, we're going to need to, well, it makes sense to look at the second derivative. That's typically like an easier thing to do, especially when we don't have a calculator. And that means we need to return to, where were we? I'd say to here, in fact. Remember, we cancelled these out. That was okay. I want to get d2y by dx squared. So differentiate again. Two x plus y squared d2y by dx squared. I'm using the product rule now on this. Plus 2y dy by dx all squared. When I differentiate y squared, I get 2y dy by dx, and then timesing it by dy by dx. So I've just gone ahead and squared it. Minus dy by dx. Minus, and then I'm using the product rule here, so I differentiate x. So I just got dy by dx. And then I'll differentiate dy by dx, leaving the x there. So that's going to be d2y by dx squared. And that is equal to 0. Not very nice, is it? What should I do first? Well, remember, for stationary points, we're only interested in the second derivative at the stationary points. Dy by dx is 0. So here, 2x plus y squared d2y by dx squared minus x d2y by dx squared is 0. Okay, and we found the second derivative. It's going to be minus 2x over y squared minus x. Probably makes sense to change that to 2x over x minus y squared. Finally, we've got one stationary point is when x is equal to 2 and y was equal to 4. So it's 4 over 2 minus 16. This is definitely going to be less than 0. So it's going to be a maximum. Then when x is equal to minus the cube root of minus 6, I'm going to write that as minus 6 to the third. We get that y is minus 6 to the 2/3, which is just the same as 6 to the 2/3, because when you square a negative, you're going to get a positive. We'll get that d2y by dx squared is equal to, now remember we're using this one, so it's going to be 2 lots of minus 6 to the third all over minus 6 to the third minus 6 to the 4/3. Okay, now this thing here is negative. This is negative. I'm just going to put a minus in. This is positive. So negative minus a positive is also negative. So overall, d2y by dx squared is going to be greater than 0 in this case, and it's going to be the maximum. So there we have it. It's quite a bit to do at the end to get that d2y by dx squared. But it's all good. Well done.